Thank you very much. My name is Takuji Nakamura from National Institute of Polar Research. So this is the title of my talk. I'm sorry I'm not talking about the future roadmap, but just the roadmap we came from the past. Okay, so our National Institute of Polar Research, NIPR, Japan, founded in 1973. And so this year we have 50-year anniversary on September 29th. Our mandate is to conduct comprehensive research and observation, so both research and operation on both polar regions, Antarctic and Arctic. We are one of the 17 inter-university research institutes in Japan under mixed Ministry of Education. So we are supposed to collaborate with universities. And our annual budget is about 4 billion yen, excluding the icebreaker Shirase operation. And we have about 240 people and about 80 professors, scientists. Okay, and we have 20 PhD students. So our station, the main facility is the Showa Station, established in 1957. The Showa is located in East Antarctic, 40 degrees east, where the multi-year sea ice is very thick. And therefore, we need a very strong icebreaker to approach our station. The icebreaker had to go to Showa Station is now 4th generation. The Showa was the first, Soya was the first one between 1956 to 61, which was followed by Fuji from 65. Then Shirase was deployed in 1983. And after a lifetime of 25 years, now second generation Shirase has been in operation since 2009. The current Shirase is over 12,000 tons, which is about 2.5 times larger than Fuji, which was the 50 years ago. And the Shirase is the Polar Class 2 icebreaker with icebreaking capacity of 1.5 thickness sea ice with 3 knot. Because of the development of icebreaker, the transportation capacity has been improved, as shown in this slide. Total cargo weight by Fuji 50 years ago was around 500, but it's currently over 1,000 tons. And the 50 years, 50 years ago, don't go up, backward. Yeah, anyway, now we can transport passengers 2 times more, over 80 per year. And Showa Station became about 3 times larger than 50 years ago. The maximum floor area around here was several years ago, and that was 8,700 square meters. Now we are decreasing the number of buildings and replacing by newer buildings. The building number was maximum here at 73, to be 73, but now it is 61, more than 10 smaller now. The next slide shows the large facilities for scientific observation in Showa Station. 50 years ago, the rocket range was the big project. We have launched over 50 rockets from Showa Station. And 1989, the JARE 30 installed 11-meter diameter large antenna system which is used for satellite downlink as well as the VLBI observation. This is the geodetic observations. More recently, the large atmospheric radar, this is the largest in the Antarctic, Pansy radar with more than 1,000 Yagi antenna, started operation, full system operation in 2015. The international campaign is revealing the mechanisms of general circulation of the atmosphere and teleconnection. Okay, development of telecommunication was also significant last 50 years. By 1981, our major communication was by HF radio communication. The situation has changed dramatically in 2004 by Intelsat satellite link, satellite internet, 1 megabps. It is now upgraded to 6.4 megabps. It is so notable that from Showa Station, the world's first TV broadcasting, live TV broadcasting was sent in 1979. And 2003, the first HD TV broadcasting. By using this stable internet connection at Showa Station, in 2021, we have linked to 10 junior high schools and carried out bidirectional interactive lecture from Showa. This event was held when Japanese government delivered the one tablet computer to each of the all students over Japan. And this live event, we had about 9,000 accesses online from everywhere, and also about 2,000 questions raised by live the program. Japan installed 3 inland stations, Mizuho Station in 1970, Asuka Station 1985, and finally Dome Fuji Station 1995. Dome Fuji Station is about 1,000 kilometers from Showa Station inland, and it's about 3,800 meters above sea level, where the annual mean temperature is minus 54 degrees, and the pressure is about 600 hectopascal, very severe condition. Deep ice core drilling has been the main project at Dome Fuji Station. The first drilling was 1995 to 6. The drill got stuck when it came to 2,500 meter depth. And this first core produced the climate down to 340,000 years ago. The second drilling was 2003 to 2007. This 3,000 meter ice core provided the history up to 920,000 years. So one of the challenges of transportation is the variation of multi-year sea ice condition around Showa Station. It changes 20 years periodicity. And in 2011 to 13, JARE 53 to 4, we could not send Shirase close to Showa Station, did not burst to the Showa Station because of 6 meter ice, very thick sea ice. The transportation was very difficult, and only 50% of cargo could be delivered to Showa Station, including fuel as well. So stable transportation is really a challenge for us. By the expansion of the Showa Station and increase of research instrument, the power consumption has also increased a lot. And annual electric power consumption is now about 1.5 to 2 gigawatt per hour. Gigawatt hour annual. And this slide shows the amount of the waste transported back from Showa Station, Japan. After the Madrid Protocol, you see the JARE is continuing the effort of cleaning the Showa Station. And about the future challenges, please see my colleague's presentation, Gen Hashida's presentation in the afternoon. Okay. That's all. Thank you very much.